Question 2, Part B, Part 1. Show that 1 minus 2i in brackets squared equals negative 3 minus 4i. Applying perfect square expansion, 1 minus 2i in brackets squared is equal to 1 squared plus 2 times 1 times negative 2i plus 2i in brackets squared. Now 1 squared is equal to 1, 2 times 1 times negative 2i is equal to negative 4i, and 2i in brackets squared is equal to 4i squared. Now recall that I squared is equal to negative 1. So 1 minus 2i in brackets squared is equal to 1 minus 4i plus 4 times negative 1. And 4 times negative 1 is equal to negative 4. So the expression becomes 1 minus 4i minus 4. Collecting like terms, we get negative 3 minus 4i as required. Part 2. Hence solve the equation z squared minus 5z plus 7 plus I equals 0. What we have is a monic quadratic equation over the complex numbers. And we have the constant term here is the complex number 7 plus I. Now we can solve this equation using the quadratic formula. Now our A term is 1, B is negative 5, and our C term is 7 plus I. So using the quadratic formula, z equals negative b plus or minus the square root of b squared minus 4ac over 2a. So that's 5 plus or minus the square root of 5 squared minus 4 times 1 times 7 plus I over 2 times 1. Now 2 times 1 is 2, 5 squared's 25, and negative 4 times 1 times 7 plus I is negative 28 minus 4i. Collecting like terms inside the surd, we get z is equal to 5 plus or minus the square root of negative 3 minus 4i over 2. Now from part 1, 1 minus 2i in brackets squared is equal to negative 3 minus 4i. Taking the square root of both sides of this equation, we get the square root of negative 3 minus 4i is equal to 1 minus 2i. So the surd component of the quadratic formula can be replaced with 1 minus 2i. So z is equal to 5 plus or minus 1 minus 2i in brackets all over 2. And this gives us two solutions. Simplifying the fraction, we get z is equal to 3 minus I, or z is equal to 2 plus I.